Thank y'all again. I'm Doug Cameron, by the way, Render ATX. And so Lily and I own this company. We've owned and operated it for 17 years now. And this is a really surreal project location for me because I walked these streets as a kid going to high school. I went to high school right up the road. And this is maybe the second or third project in this area that I've got the opportunity to redo a new house on. So it's a lot of fun getting to build in your old neighborhoods. And obviously we want to leave something that we can be proud of. And so air sealing is really the topic of conversation here. And we're not going to just focus totally on the air sealing. We're also going to focus on the use of the blower door test and how to actually use that to your benefit versus just kind of something that's an after the fact metric that you can't really change.
Do you want to talk at all? Do you want to give any details about the strat? I don't know if everybody knows here about the Zip 2.0 system.
I'm going to get into that. Okay. Yeah, I'm going to get into that.
Speak a little bit about that. Mm-hmm.
Yeah, totally. So that's where I was going. So this has been about an 8-year evolution of a system that I've been working on. Peter actually came out to, I think, maybe the very first home that I ever did this on. And so the system has been called Block and Caulk. It may kind of sound a little bit crude, but the idea was I wanted it to be extremely simple and straightforward to understand. And in a nutshell, kind of how I came to the place where I felt like there was a need for a system like this. My wife and I live in the Onion Creek neighborhood. And there have been 2 major floods in that neighborhood, and one of them really piqued my interest. So it got me going down multiple rabbit holes for how I could create fire-resistant, flood-resistant homes. And as I was going down that angle and that rabbit hole, which was a deep one of the things that came to light was the idea of using these fluid-applied house wraps. And I dug in deep, and then I realized, man, these fluid-applied house wraps really, I think they're the future. And so I saw something, and I was like, I'm just going to run with this. I'm going to be one of the first people to jump in head first with this fluid-apply house wrap methodology. And so so once I kind of had that in my hands, and I was playing around with some fluid-applied. Fluid-apply is like basically, y'all see that, any of these windows or anything like this right here, like this is fluid-apply. It's just a moldable waterproofer, and it's not really like just a caulk. The majority of them are sill-terminated polyethers or sill-terminated polyesters, and that's like a real long, confusing sounding name, but they call them STPEs or something along those lines. And what's so good about them and brilliant about them is that they're very stretchy and they're totally moldable. So when Zip first came out, me, like most other people, really had a hard time and struggled with the idea of a tape because we've been ingrained this whole idea of shingling for waterproofing, and the tape wasn't shingling. Like, it was not that. It was contrary. So it was like, I don't know about that. And so I didn't like the tape for a long time, and I never really used the tape for a long time. This house is actually one of the first houses where we've actually used the tape pretty heavily. So that was kind of a newer thing for us as we wanted to continue the evolution of this system. We wanted it to not cost $1 million to do. So that was really why I figured, we kind of got something figured out with using the fluid applieds, and it was working brilliantly.
And we can talk later about a cost analysis difference where we've actually done some scenarios where it's all fluid applied and then a combination of tape and fluid applied to kind of give that comparison to clients. And also another custom home we're building that's a similar size, we did the other way so that we could do a little bit of a comparison also with the blower door test and some other factors. So
yeah, and just kind of for visuals, and y'all can take these home and stuff, but just kind of for some visuals, this is the house that Peter came out and saw, the very first one, and you can see it's just Zip, and it's got a different brand of the fluid apply. That was the Tyvek brand, right? And the reason why I'd gone with that Tyvek brand one is I didn't even really quite know that Zip had a fluid apply that they sold at that time. And I had, when we first got into the fluid apply, we fluid applied the whole exterior. And so we did that. We've done that on 2 projects.
Which can get a little expensive.
It can get very expensive. It works really well. You see it on commercial buildings and stuff like that. And so my team was trained by the Tyvek reps on how to actually execute all the joints and seams and the whole 9. So once we kind of got that down, we saw the vision of being able to utilize a panelized exterior waterproofer like a WRB, like a Zip, and that would be more efficient because you would have to put less of that fluid apply, but you still had something that seemed very monolithic. Now I know it's not like truly monolithic because it's two different materials, but the way this stuff molds to the other materials, it feels like there's no seams that you can really get at and pull off or anything like that. So anyhow, we got here and then we continued to progress this idea. I think the outstanding metric that we saw was we were able to achieve under 1 air change per hour every single time that we've done this. And that's pretty amazing. And every
at this stage.
Yeah, at this stage. Yeah, you know, it happens afterwards too, and sometimes it can be after. I don't think we've tested all of them in the past at this stage, but it's very valuable too, and we should have been if we weren't testing all of them.
Well, and then, you know, if you've got a roof penetration and you've already got your roof on and you do this test and you know you've got a hole there, what are you going to do? Rip your roof off? Like,
Totally.
It's a big pain in the ass. And I mean, ultimately, you know, our training is what's measured is managed. And if we can find where we might have a failure or we might have an issue at this stage, that's great. That's a great indicator of, you know, one, what have we done well and where did it work really well, but also what did we do wrong or what did we not do so well so that we can do that better and fix that for next time. Because I think as we continue to evolve in this industry, it's really important to have a bias for action and also try new things and see where, hey, maybe it's okay to fail sometimes, but as long as you're failing fast, learning from those failures and moving on.
Mm-hmm. So she's really talking about points of control, right? And by that, what we mean is exterior claddings, exterior roof. So for this system, the way we preach it is we say that we recommend, and you know, again, I just can lead by example. I'm not telling you what to do, but we recommend doing no finishes until you have tested the house. Because we have learned over time that once you lose control over one aspect of the exterior of that envelope, it's gone. You no longer can get back to it, and now everything has to be sealed from inside, and it becomes super convoluted, super confusing, and it just basically becomes a nightmare to try to improve your air sealing. Now, since then, there's new technologies like aero barrier and stuff. It's like, you know, a spray, you know, it's kind of like an aerosolized caulking that you can spray. So, you know, if we wanted to, if we didn't know how to seal from the outside and we needed to improve our scores, we could bring aero barrier in here. We could pay, you know, X amount of thousands of dollars. And I'm not knocking the product. I think it's a wonderful product. We've used it on at least one project, like a retrofit, and it was super helpful, and it was the only way we were going to get it done there. But my point is, in the aero barrier, people will all tell you too, if you can just seal from the outside, that is by all means the best way to do it and the best practice. So what, you know, with the points of control, it's like, again, we're trying to teach you a way where you can structure your plans, where you can design your plans to have a streamlined effect on the whole project. Because what I constantly see is the architect and the builder have not really talked every aspect of this out. And maybe some builders like Peter Pfeiffer might be detailing this to this extent, right? And that's awesome. But a lot of architects really are not, and maybe just are not, frankly, that experienced with the building enclosure. Like, they're focused more on beautiful architecture and, you know, all kinds of other variables within the home outside of like being, you know, hyper focused on the building enclosure itself, the building envelope. So anyway, we have now made and set up a situation where we can have control and access to the entirety of the outside of the envelope. And we've got all of our MEPs run, you know, mechanical, electrical, plumbing, all the penetration. So like, we had plumbers come yesterday and they put in a bunch of pipes and stuff like that. And frankly, like, it smelled awful. It was awful. You might catch a tiny bit of it still. We were trying to squash that, but that is a reality, and that's part of what I wanted this presentation to be about too, is reality. Not just some like fancy YouTube video or Instagram or how perfect we are and, you know, blah, blah, blah. I wanted to kind of share some of the pain and agony that we experience as builders, and how even with giving really good recommendations and having really good process, that sometimes stuff just doesn't get executed the way we want it to. And so the idea of this system is that you have the opportunity to remedy your mistakes. That's really the big, I guess, message that I'm trying to share with you. And back to the detailing, you know, we can kind of walk around and look a little bit more later, but the short end of it is, I recommend strongly that you detail your plans to where you can take your sheathing up to your roof decking continuously. And I like toothing around any rafters that come out. That's my preferred method. There's this other, monopoly framing method where you cut the rafters and you take everything continuous and then you add the rafters back later. That's a way, works great too. Not one that I've really practiced, but that is another option on how you can do that. I prefer the toothing of the sheathing. And I'll tell you what my framers have always told me is, hey, if you would have told me that at the very beginning, that could have been so much easier for us. So that's why I'm telling y'all at the very beginning, you can make it so much easier on everybody by detailing your plans to say that you want the sheathing to go to the roof and that you want to tooth around the rafters. And then if you get any big triple, quadruple beams coming in and out, you really are going to need to squirt some goop or something in between those beams. That's one of the few areas where, because this whole system is about air sealing from the outside. Outsmarting air from the outside is what the article is called. But there's maybe a couple of places where you are going to have to do something that is from within. And so when you have rafters or big beams that are going from in to out, that there's a lot of air leakage that occurs there, believe it or not. And we'll see with the smoke test here shortly, because this house is not perfect yet.
Has anybody else ever seen a blower door test live? Okay. So we've got a good amount that have it.
I agree with your system, Doug, 100%. Sounds great.
Thank you,
awesome.
Thank you. So lastly with the system, let's see.
Do you want to talk a little bit about how we set up for this test?
Yeah. I guess I just wanted to say on the detailing deal. The other real whether you do tape, whether you do fluid applied, whatever you do, and we're really playing around with mixed variety because there's a lot of good tapes and stuff out there now. Like Sega has great tapes and stuff. But I want to hit home the super key areas that I have identified as huge air leakage points. And so that sheathing to the roof one is the number one. And we can call that bird blocks. That's kind of easy term that I use. And so a lot of times those bird blocks, like if you have a deck like this or something and there's no water intrusion issue, sometimes those bird blocks are left wide open. And they're left like that forever. And that's just how it is. And on that very first house where I measured the air, there was a huge air leakage in all the bird blocks. And I was like, oh my gosh, that's crazy. So when I started trying to figure out air sealing, I looked at some stuff from California. I saw Tyvek detailed in California with an air barrier where it was sealed to the base plate. Kind of like the foundation to sheathing area. And that was the first time I had ever seen that sealed. And I always thought that was wrong because I thought you needed to leave like a weep somehow at the bottom of the sheathing. In this case, the Tyvek. And you look at windows that way where you weep the windows in the bottom. So it was a big epiphany to me. And I was like, holy cow, you can actually seal that and like nothing bad's going to happen. So went down that rabbit hole, realized, wow, you actually can. So one of the I feel like good ideas I brought to the building world is using this fluid apply to take the sheathing to the foundation and sealing it right there. And there's massive air leakage that occurs there. So once we got the bird blocks figured out, once we got the foundation to sheathing figured out, now it was just kind of like penetrations and the beams and kind of random stuff. And it got super easy. But it can go bad. And like even on this project, even when you work with some of the same framers over and over again, at times they hit you with random real life stuff where they send over a different crew. They're in a hurry to get the roof done. They don't detail my sheathing to my roof exactly the way I wanted. And next thing you know, like they want to come back with some can foam and seal it from the inside because they realize they kind of messed up. So then I'm having to go deal with the agnet. But I'm just letting you know, like, this is what other builders are going to be dealing with too. Even with good framers, you're going to deal with this at times. And you have to try to get everybody bought in. And one of the easiest ways and analogies is just explain that you want the house to be a balloon and you don't want any air leaking. And you don't want any light coming through and you don't want any air leaking. So I'll kind of stop right there in terms of the system, and I'll just say, hey, once we identified those key leakage points and we address those, our blower door scores, became phenomenal. But now we're here doing the test. How I recommend using this test is, I've done it in the past many times, like where it's at the end of the project. It really doesn't help you much at all because it's at the end of the project. So the best time is right now. So we just finished with the MEPs. We got all the penetrations done. We think we've done a pretty good job. We've had a couple of issues with the framers here and there with some details not going according to plan and a little fighting and tug of war and trying to make it happen. But again, life is not perfect. Our projects are not perfect. We try, we do the best we can, but it's not perfect. So we test, right? And John, what do you always say? If you're not testing, you're guessing?
Not testing, you're guessing.
That's right. I love that. And John and I, we actually grew up together, and this is the first project we're working on where he's the AC installer, but he's also did the HVAC design for us, and he's done performance testing on multiple projects for me. And so he's an awesome guy. He's been a great resource here. And
so highly recommend Jon, if you guys want to do this on any of your projects, definitely reach out and get his contact info, because this is, I mean, such a great resource.
Yeah. And so what Jon did different too than any other performance tester is he brings out this massive smoke machine. So I thought I kind of knew air testing before. I even made some videos saying, you don't really need a smoke machine. You can hear the wind whistle and this and the other. This smoke machine, like, it's the way to go, 100%. And so what we're gonna do, we just got all our temporary ACs sealed up, right? Again, there's gonna be some imperfections here. That's fine. We're shooting for 1 air change per hour, but if we don't hit it, what we're gonna do is we're just gonna keep working on it until we get to the 1 air change per hour. So it might not be today, but by the time we get done with this project, because we have left ourselves all the points of control to be accessible from the outside, and if any of them have been goofed up and we have to do something from the inside, we're gonna have to methodically do that. We don't ever want it to be that way though, and I constantly preach to my team, it should always be from the outside. If we're having to do it from the inside, we made a mistake. So
and with the smoke, it's really cool when you do have an error or an issue, you walk outside, you see where that smoke is, you know where you've got the problem, and you can address it immediately. So it saves your team time, energy, and you know what the actual status is of your building envelope.
Right. Yes, sir.
I want to add something. When he's talking about sealing the base of the house to the slab, that's also a fantastic bug deterrent. Developed a detail for this about 30 years ago when I was realizing that houses rot at the bottom of the walls because of water falling off the roof, backsplashes against the lower part of the wall, and sprinklers are usually not aimed right. So we started putting this rubber layer off the base of the house, and it was wonderful when I built my own home. I think in many decades there, we've had maybe 2 or 3 bugs in the whole house. That's it, over decades. So it's a great bug barrier.
That's awesome.
Absolutely. I know that the house that Lily and I had as our first home that's a rental now, we constantly had cockroaches coming up that exact area, and she hates it, and she would yell at me every single time, deal with this. And so that is a great point, Peter. You really want to keep all these weird things out of your house. You just want to control. And like I always tell people, once we started ACing homes, we gave up this whole concept of like, this house is breathing. Now we're depending on a whole bunch of other scientific stuff to achieve a good, healthy home. And it's okay. And it does work well. So without further ado, I think we're ready to test this. You have anything else before we test it? Okay. Good. I think we're ready to test this thing. Yeah. Do you want to say? No, jump on in, Jon.
So, guys, everything to get started. So how I approach this process. First thing I'm going to do is I'm going to set it up to get our number first. So y'all can follow me up there. We're going to see our numbers. And there's 4 different ways I read the blower door, and I can explain that to y'all. Second thing, once we have our number, we're going to come to key locations. I'm going to first fog this area first so you can see the fogger, how it works. And then y'all can proceed outside, and then y'all can see where the areas are leaking. But that's the best way I think y'all should look at it to get the full experience of testing and actually me running the blower door.
Awesome. So you want us to run upstairs first?
Yeah, we'll turn it on first, and I'll just run through the gauge real quick and how we do it. And if you got any code questions or what the code enforcer is going to look for, how do you do your energy finals, I'm here to help you with any questions.
Yeah. Okay, cool. Let's go upstairs then.
So there's 2 different ways to do the blower door. There is positive pressure and negative pressure. So most of the time, your third party and tester, your finals, are going to do negative pressure testing, okay? For this test at rough, you have to do positive pressure. It's going to be the worst scenario test, and also going to push open dampers sometimes, okay? Now, when we positive pressure, it's going to fill up the house like a balloon. Okay, so first thing that we do is we use a manometer. This is from Retrotech. It's a real sensitive manometer. It measures off pascals. Pascals is such a fine measurement, it can measure the way an ant would fart. Okay, it's real sensitive, all right? So we're going to measure at 50 pascals, and then we're going to read first the CFM number. That's an important number because that's how we can, and it, to be correct, it's CFM at 50 pascals. We can see that number so we can see our starting number, whether it's 1,000, 2,000, and we can know how to reduce it down by numbers.
Do we need to make sure?
Next, I'll show you ACH. That's air changes per hour at 50 pascals. That's the code. Most codes, you only have to do 5 air changes per hour to pass in climate zone 2 where we're at. Okay, so that's a real crappy number. Okay, most foam houses or high performance houses should be around 2 to 3 ACH. Passive homes are hitting on the 1. All right, so let's get it started. All right, so go ahead and do this manually. Turn it on.
We got Laura's coming in, but I'll tell her.
All right,
Yeah.
go ahead.
Come on, Laura.
Automatic mode. So first thing I'm going to do is read CFM. We're at 93.
Here. Here. Good, buddy.
All right, so we got the rings on here. Let's bring this guy down. Let's see where we're at. It's going down from 80 pascals, 78. Let's turn down a little more. We're going to bring it down to 50. There's usually an auto mode with this, but as you can see, my tester has ran a lot of miles on testing. All right, so we're getting down a little lower. Get to about 50 pascals. We're going to rev it down. All right, so right now it's about 755 CFMs at 50. That's a phenomenal number. If we're looking at this number, I normally like to tell people, whatever the square footage of the house is, I like to see 70% of that number. So if it's a 2,000 square foot house, I would like 1,400 CFMs. That's a controllable house. So we're at 50 pascals, right around there. 49.7 is, I have to be right on the money, but it's really close. So 800 CFM, 50. Now we're gonna do ACH. So right now Doug is at 1.9 ACH. So this is a phenomenal score for third-party testing, way above the basic minimum. Now the other test I do is I like to say, hey, how big is this hole? Like, what am I looking, all these little tiny holes up there, what kind of dimension is it? So this is about 82 square inches. So what is that, guys? Like maybe a 10 by 8 hole? It's not that big. That's phenomenal.
10 inches by 8 inches.
Yep, 10 inches by 8 inches.
The whole house.
The whole house. So all the little pinholes. And I always believe people, I say, hey, it's death by 1,000 cuts, right? All these cuts can add up, all right? Now, on some other ways I do for home performance, I like to see how much CFM it is per square foot. So again, going back to the rule, a controllable house is 70% of the square footage. Well, this is about 20% of the square footage. This is phenomenal. He's hitting in the areas of beyond a controllable house. This is, yeah, we are hitting that. Lastly is the CF, yep, I think that's it, guys. So we got the 4 tests. CFMs, CFM at 50 pascals. We got the CFM per square foot. We got the air changes per hour at 50 pascals, and then the equivalent leakage area so we can kind of visualize it. That's the blower door here. So we're gonna put this guy, let him run, make sure that we're still at 50 pascals. Yep, right around there. And we're gonna do the fogger. So I'll do the area that is gonna be the most troublesome one I see. And, or what, Doug, you mean just start up here and then work our way down?
Yeah, whatever, dude.
Okay. So I'm gonna start in this corner over here,
Yeah.
okay?
And what about safety and health with the fogger?
So safety and health, this is, there is some information down there. So this is basic theatrical fog. It has no chemicals in it. It's what they do. If you're any worries, please stand downstairs. You take a look from afar or protect yourself. Everybody, y'all should know your own health risk. We're not responsible for any of that. But I breathe this stuff. I'm gonna be here, I'm gonna be doing it. I feel safe and I love my kids. I don't try to do anything dangerous. But if you want more information, there's down there or on my Retrotech kit, you can get that. Are we good? Anybody has any objections?
We're good.
All right, so here's the Retrotech fogger. It's from Retrotech. It's the large fogger. This ranges at expensive price, but it combos with the blower door. It's one of the best ways. So this little hose we customize, you just point it in the direction and then it goes. So we can go to the base plates. We can go all the way down. And now outside, if there was any leaks at this base plate, you're gonna be able to see it going out outside. The most notorious place that people are gonna leak is this little place right here in this corner. Now, sometimes I use this to watch the smoke because if there is major air leakages, it's gonna go through that hole. And if you could see it, it's popping out. It's trying to find another place. There's a leak somewhere, it's trying to find it. Okay, so this is how I use this. Now, we'll do one more place downstairs and then where y'all can really go, because this is a team effort practice. You gotta have someone outside with radios or on the phone communicating to each other. So let's go ahead and do downstairs and let's see what we got going on. before I go on this way so y'all can see, this is a good tool for the builders here. You could see this for before, during, after. It's called the Retrotech Mini S. I could pass it around, y'all can use it, but it also does decent amount of smoke. So you can see if your kitchen hoods are working. You can have this running around if you were doing this yourself at home. So I'll let you pass it around if y'all want to see it. Be careful at the top. It is do hot liquid. If you don't want to taste it, you don't. Please give it back to Ruben when y'all done.
Don't inhale it.
Do what you want. Yeah. It's not going to do you any good. So 2 places. So this is going to be a key area that's hard because the building kind of overlaps it. Can you help me explain that right here, Doug?
Yeah. So anyway, you've got
Daylight right there.
yeah. So that's going to be
key
that.
indicator.
That's probably going to be a bad point. I do know there was some clear caulking that was used on the outside too, so it's possible that that's the case. But yeah, what you know, when you have the modern farm style homes that have no real roof overhang or anything like that, like that's a super easy one to do. When you start getting more articulation and changes of elevation and roofs that have a lot more angles and stuff, it ups the ante a little bit. It should be really simple though, still, because you're still doing the same thing. You're blocking and caulking, and I always like to tell people it's like finger painting from the outside, and you should be able to see everything. So like how Peter said, you can see light out there. From the outside, my team should be able to see that crevice and should be able to put the finger painting of the fluid applied on top of that, and that should go away. And so if they haven't done that, or if we're having to do something from the inside, and I'm going to show y'all, we've got some spray foam that you see, can spray foam in some areas. That's because we didn't do it right everywhere. My team didn't do it right everywhere. So we saw that, we knew that, we were proactive. But I'm telling you, like for me, that irked me to no end, and I just kept stressing to my team. But again, I'm giving y'all real world here. Kept stressing to my team, guys, it's always got to be from the outside. If it's not from the outside, it's not right. And so we have some areas that are not right, and they might be some of our weak areas.
It's great.
And a lot of things I tell people, the building world and the mechanicals. Do you know how many times you air seal? You air seal. You air seal. And guess what you do? You air seal again. Usually takes 3 runs to get it to where you want it. So don't forget, that's also with mechanicals. Okay. All right. There's one other place I want to show after we do here that was could be a potential problem. So I'll show you all that too. Mm-hmm. All right, here we go.
Yeah, and keep in mind you've got positive pressure going on right
so
now,
it's
so it
pushing
should
out.
be pushing the air out of any crevice.
Pushing it out to the outside. Yep.
And so when it's staying like that,
That's good.
That's a good thing. You'll see it coming out. You'll see it probably.
Yeah, and see,
outside.
interesting,
You can look
Peter,
out
it's
window.
not really finding that area.
we know we've got an issue where we can see it.
So I'll refog these 2 sides on this side, so we all focus over here.
Yep.
Y'all go outside. Let me
Yep.
show you this other area right here that I think.
Yeah, let's do that, and then let's bring everybody outside and try to see what we can see. It is because it is a clear caulking on the outside in that area, and that's why.
All right.
Yeah. Yeah, so part of the whole evolution was playing around with some different materials too that were maybe more cost effective. So for the areas where we only needed air sealing and not waterproofing, we've utilized a different caulking there, and it just happened to be a clear one. So that was that. But yeah, it's kind of deceiving. I don't know if I'll do that again.
So Doug, this area, let me talk a little closer.
Yeah, this is a good example of a tough one, right? You've kind of got a wall that's not a just clean wall. You've got some stuff going in, some stuff going out, and again, when you stress to the framers, the whole process and timing and sequence of how they frame and how they sheathe is very important. And if somebody isn't playing by your rules, they will screw you, and you will be pissed, and you will not get the results you want, and it will be a lot more hard work to fix it. And so that very well could be the situation here.
So you happen a lot. There's a deck on top.
Yeah, there's a deck
so
out there.
There's a walkway up there.
Right.
So these are things that you got to pay attention. I'm thinking the guy's thinking about how the water's going to flow off the house.
And another big thing is like you really don't want wood added to the sheathing until it's all been air sealed. That just pisses me off to no end when I see it. I'm like, no, and then they'll put the wood right on a seam or something, and you're like, dude, now I got to seal the wood to the sheathing. Who wants to have to do all that? So again, for your detailing, I would recommend that you have the sheathing continuous to the roof line, and it's all sealed before any other framing members or wood gets attached to that sheathing. Yep.
And I'll keep on smoking while y'all are outside so y'all can see. But I usually hit these areas, and then also on the first floor, you want to make sure that you hit that bottom plate. This one's where it's really important at, especially in these corners right here. This is where you're not going to see. I don't know anyone got that kind of X-ray vision yet, but that's going to be the biggest area. All right, so y'all welcome to go outside. I'll keep on fogging between these two.
Yeah, so for communicate, where are you going to be so we're communicating well?
I'm going to be rotating like this, back and forth. I'm just.
All right, let's just talk at windows type deal.
Tap at windows?
Just tap at windows. Yeah, let's go outside, guys.
Anybody see any smoke?
Okay, this is the most fun is when you're outside. So we'll say, John, you want to go?
You see some?
Right there. Yeah, there.
Yep. All right.
Yeah, we're over here. Okay.
We've got some issues. That same spot.
It does that spot.
Whoa.
Yeah, watch out for that hole.
Yeah.
Don't want to lose you, Doug.
So basically, guys, this is telling me that's from the side of the window frame. There's a little screw or something. And that's, we can do better on that, right? And so typically what we'll do is we'll have somebody out here, and usually they'll have some tape like this or something. And we'll usually do video too, whatever. It's kind of a mixed bag. But you kind of just want to mark. Yeah, you want to be like, hey, look. Yeah. So look where it's coming from. I mean, y'all get down, y'all can see it's coming from the little holes in the tape where the tape's been dinged. Yeah. So anyway, you just kind of document, right, and then you go rectify afterwards.
Would you like do
Hey,
another?
Peter, thank you so much for coming. I appreciate it. Nice job. Thank you.
Doug.
What's that?
Would you do like another layer of tape? Like how would you?
Oh yeah, so the solutions are pretty easy, and it could be another layer of this tape, or it can be some of the fluid apply, which is in a caulking tube. So it's just kind of whatever's easier. The other one that we can use is the can spray foam from the inside. But what did I say earlier? I hate that. That's not the way. I hate spray foam. I hate the smells. I hate the odors. I hate the chemicals. And we failed if we're having to do it from the inside. Sometimes we failed so badly that we have to. And we have to just own that and fix it. But anytime where it's from the outside, that's easy. And that's what I'm trying to teach y'all. And I'm just trying to say, hey guys, really pay attention to this and have this done from the outside before all this other stuff gets added. And it will make everybody's life so easy. And it'll open up all these opportunities. Where's our smoke at? I don't want to lose him. Okay, let's go. Yeah, I don't want to lose him. Let's.
So burn blocking.
So right here, guys, look at that. So see this? They did what I was telling y'all. They didn't do the continuous sheathing all the way up at once, and they ended up patching it back, and then they put a piece of wood, and they left themselves a real hard time to get the sheathing there. So they basically, they added this wood before we were sealed, that 2x4 that you see, and that is not the protocol. And so they need to know that, and if you can articulate that on your plans, like sheath and completely seal before adding any other members to my sheathing, that is what you need to tell them. And if you do, that is so easy to air seal. If you don't, it becomes a huge nuisance, and it's going to be an air leakage point, right? Any questions on that, like from a functionality of actually being able to do that in real life? No?
Well, I guess, I don't know, it seems like a means and methods thing, and I don't know how, as the architect, I guess just talking to the contractor and kind of getting a good sense
Like,
of
what is their strategy? And being clear, and like having enough knowledge in your bucket to know when to call bullshit is actually, can be a strategy of its own. Like, okay, well, what is the strategy there? If there isn't one, then that's maybe a problem.
Well, I do a lot of consulting for other builders and for architects as well. And so I typically tell them, you need to identify your strategy, and you can claim the strategy. You don't have to ask the builder to claim it. You can claim it. And sure, it can be the other way around too, and that's fine. But to go in with no strategy is like me going out to my football field with no play or no plan. You're just going to kind of struggle.
Well, and understanding, like, if you do have bird blocking, how are you going to handle that? And there's all, there's different strategies depending on, how it's framed.
Right. And so spray foam is the typical solution that we've been seeing for the last 10 years plus to a lot of these air sealing problems, and that's why you'll see a little bit of the can spray foam inside. But I think it's a terrible approach to air sealing personally for a myriad of reasons. I won't dive into all of them. But the brilliance of this system is you no longer need spray foam. So now you can just use insulation as a resistance factor material for thermodynamics, and you're not worried about air. And that is awesome. And with that, now you have a new opportunity, right? A new opportunity to place a new material inside of almost the entire home. That's a big material that you're picking. That's a big chemical composition. And so for us, we've leaned on stuff like blown-in blankets of fiberglass, which are formaldehyde free. We've leaned on hemp insulation, and we've leaned on rock wool. The most cost-effective
So we knew
approach
this one was
that
gonna
I
kinda
think is
be
really cool, that's like a good hybrid, would be to do blown-in fiberglass blanket up in the roof area, because it's hard to piece all of the pieces of bat insulation up there. So you can do a blanket up there. And the really cool way you can add a lot of R value to that roof with a blown-in blanket that we've come up with, it's taken like some trial and error to do this, but it has a net. And so the rafters are only so thick, so you can only get so much insulation. R21 is the insulation value per code if you use spray foam up in the roof. It's R38 if you don't use spray foam. Why do you think they're giving you the R21 pass? Any ideas with the spray foam?
It seals it in. It's a better. It's like what you're doing with the.
Because of the air sealing.
The air sealing,
It's
yep.
because of the air sealing component, right? So when we do this, we have to achieve R38 if we're going to go away from spray foam, and it's actually like way better because you'll get way more R value than the spray foam. So per inch, like a fiberglass or a rock wool or a lot of these other insulations actually have a better resistance factor per inch than spray foam. Spray foam just has the air sealing component. So we're just saying, hey, we'll seal it from the outside, right? And then we'll be able to put in whatever we want from the inside. And so we've taken that net many times when the rafters are not deep enough and draped it and stapled it and draped it and stapled it and draped it. So then, like if you have a 7¼ inch rafter and you need, let's say, 10 inches of insulation, then you're gonna take and drape it like to about 11 inches, or excuse me, to like 12 or 13 inches or something. And then you just divide it. And you take an average of that. And now you can provide that to the city, and they will totally take that. And like we've ended up with our systems having like R44 insulation values for our roofs typically, and it's air sealed better than every spray foam house that I've ever seen. Because we've had the tightest homes in Austin doing this system at this stage.